I welcome all the students. Today we are going to learn the topic, the circle drawing algorithm. Okay, so which algorithm is used to draw the circle? So let us start the discussion. I think we should start considering the different properties of the circle first. Okay, so as we have to draw the circle, we are going to consider which are the properties of the circle. Okay, so the first property is a circle is defined as a set of points that are all at a given distance r. Okay, so for the circle, what is necessary for us to consider is the radius of the circle, that is r. From the radius is considered from the center position of the circle, and the center position is denoted with the help of x and y point. Okay, but we have written it as the xc, small c, okay, at this. So it is the center point. C for center. We are having xc comma yc as the center of the circle and r as a radius of the circle. Okay. Now the distance relationship is expressed by the Pythagorean theorem in Cartesian coordinate as, so what is the expression that we are using for the equation of the circle we are using is, now xc and yc, as we have seen, xc and yc, these are the center of the circle and r is the radius of the circle. So we can say that, okay, or general equation we are having x square plus y square is equal to r square. Okay, but we are considering it with respect to the center of the circle. So we are using here as x minus xc square plus y minus yc square is equal to r square. Okay, so already we are using the equation as x square plus y square is equal to r square, but we are considering this with respect to the center of the circle. Okay, that is xc and y. Okay, now we have just look at whatever we are talking about. We just see with the help of this diagram. Okay, so in this diagram, what we have shown in this figure is shown is circle with the center coordinates xc and yc, and the radius is r. Okay, so you can find that this is my circle. Okay, this is the center of the circle. Okay, I'm just plotting it here. This is my center of the circle. Center of the circle, what is the x value? I consider it as a xc. Okay, and the y value is yc, and this is nothing but the radius of the circle. Okay, so we are considering this is r, the radius of the circle. Okay, that is what we have considered. Okay, now here, if we want to calculate, if the radius is given to us, a radius of the circle is given, and we have to plot the circle, or we have to draw the circle. Okay, so what we have to, we can calculate the points along with the circle boundary using the polar coordinates r and the theta value. Okay, so we are consider r and theta. So if I consider this expression, so expressing the circle equation in parametric polar forms, we may use this a pair of the equation initially, where x is equal to xc minus r cos theta. So the value of x, the x point is calculated as xc plus r cos theta. Okay, whereas we can calculate the y is equal to yc plus r sin theta. Okay, so we can, using this equation also, we can plot the circle or we can draw the circle. But if we use this equation and trying to plot the circle, okay, so you can see this particular another diagram where positive half of a circle is drawn. Okay, so when we are drawing this circle, this is I consider as the according to the radius of the circle. Okay, so I consider this is radius. Okay, this is also equal to the radius. Okay, so each and every point which is on the path of the circle is drawn, and it must have the equal to the r value, that is our radius. Okay, so we are considering it as according to the radius of the circle it is plot. But if I use the, for plotting this equation, okay, using the cos theta and sin theta values, then somewhere I'm finding my circle is not drawn appropriately. You can find there is a gap between the circle. Okay, so circle has not plotted correctly. Okay, so we are trying to use some different method. Okay, one another method which is more easy for us to perform the calculation and to plot the circle. Okay, so this point, this slide clears you to plot the circle, to draw the circle what is needed is we should know what is the radius of the circle, okay, and we must know what is the center of the circle. Okay, that is xc and yc is the center of the circle, and we are using the equation as x square plus y square minus r square, okay, but with respect to center of the circle. So we are having x minus xc, we are having y minus yc square, okay, is equal to r square. Okay, so with the discussion, let us move to the next slide, okay, so that we can come to some important algorithm for circle drawing. Okay, so I continue with the midpoint algorithm. Now here I have added the word as midpoint algorithm. Okay, so previously we have seen the circle drawing, that is a normal how it is drawn, but now we are using the algorithm that we are calling it as, it is a midpoint algorithm. So it is known as midpoint circle algorithm, the midpoint algorithm for circle drawing. Okay, now here what we can do is the computation. So if I use the previous equation, the computation may increase. Okay, so the computation can be reduced by considering the symmetry of circle. So now what we are using to draw the circle, to plot the circle, is we are going to use the symmetry of a circle. Okay, the shape of the circle is similar in each quadrant. So now we are taking that the symmetry of the circle in each quadrant, okay, or in each different quadrant, okay, that we are going to consider here. Okay, so what we are going to consider is, we can see that we can generate the circle section in the second quadrant. Okay, so where we are going to generate it, we can generate the second quadrant of the xy plane by noting that the two circle sections are symmetric with respect to y-axis. Okay, now to consider this, I think we should see this diagram. So I want everyone to just look at the diagram that we are having to understand the symmetry of a circle. Okay, to understand a symmetry of circle, calculation of circle point x and y is one option can be held. Now what the thing that we want to mention it here, or what we want to consider at this stage is, okay, so this is my first quadrant. Okay, as we have seen in the Breslham's line drawing algorithm also, it is divided into the number of quadrants. This is my first quadrant. This is my second quadrant. Okay, this is my first quadrant, my second quadrant. Now what we can say is, what is the meaning of this symmetry is, suppose I got this particular values, or if I got the circle path or the pixel of this quadrant, I will get the reflection of this into the second quadrant. Means from first quadrant, I will get the second quadrant, which is a reflection of first quadrant. Okay, reflection means, so you can see that suppose I am having the point. Okay, suppose I have got one point on the path of the circle as x comma y. Okay, if I got x comma y point, so what is going to happen is, I will get the reflection of this point over here. See what I'm saying, reflection of this point, I will get it here, and the point in this case, what will happen, only the x value will be minus. So I get it as minus x comma y. Y will not change, y will be as it is, so minus x comma y. So I will get the reflection of one point, which when if me I get the all pixels on the first quadrant, I will reflect it on the second quadrant. Okay, that is what we have written. We can generate the circle section in the second quadrant of the xy plane by noting that the two circle sections are symmetric with respect to the y-axis. Okay, is it clear? So now what we do is, now if I get the half of the circle in this particular part, I am knowing what is the first quadrant. From first quadrant, I will get the second quadrant, and after getting the first and second quadrant, okay, what I will achieve, I can achieve this third and fourth quadrant. Okay, so it is possible for me to get, so this is my third quadrant, even though this is the third quadrant, okay, and this is my fourth quadrant. Okay, so that is what I have written. The circle sections in the third and fourth quadrant can be obtained from sections in the first and second quadrant by considering the symmetry about x-axis. Okay, so this about x-axis, all the points are reflected here. About y-axis, it is reflected at this side. Okay, so if I can calculate, okay, the circle, okay, at one quadrant, okay, means I have to calculate the points of the circle at one quadrant, I will get for the remaining quadrant. So because from the first quadrant, okay, from the first quadrant, if it is reflected, I will get second, first and second, I will get third and fourth respectively. Okay, so this is what, by considering the symmetry, it is possible for us to reduce the computation. Okay, so there is no need to calculate all the points of the circle. We have to calculate only the points of one quadrant. Okay, so the same thing, whatever we are talking about quadrant, can be applicable to the octant. Okay, so I'm dividing my circle. Okay, so that is what I have written here. Okay, so there is also symmetry between octant. Okay, so we are having the symmetry between the octant. Circle section in adjacent octant, actually this is 45 degree. Okay, so we can consider with respect to 45 degree. You can find here in the diagram we have shown. Okay, I just changed the color of my pen. You can find that here it is 45 degree. Okay, so now if you can look at this particular diagram. Okay, so this is the diagram, this is my one octant. Getting me? So I'm having, so I have divided my circle into 8 octants. First, second, third, fourth, fifth, all these octants are there. Okay, so there is also symmetry between the octants. Okay, circle sections in adjacent octants within one quadrant are symmetric with respect to 45 degree. Okay, so here it is actually 45 degree. 45 degree line dividing the two octants. Okay, means if I get the calculation of one in one octant. Okay, suppose I get the octant of this, I will reflect this and I will get this octant. Okay, so if I calculate for one octant, I will get reflection of the second octant. Then I will get the one quadrant. One quadrant reflected, I will get the second quadrant. And reflection of this half circle, okay, I will get the reflection, I will get the complete circle. Okay, so this is what help us to reduce the computation is reduced. So our task or our problem is now reduced. Okay, what we have to calculate? We have to calculate the pixels of only one octant. Okay, only one octant pixels are calculated. That is sufficient for me. I will get the next octant, I will get quadrant, I will get two quadrant, I will get half of the semicircle, I will get the complete circle. Okay, so that's why we call it as the midpoint algorithm. Okay, having a reduced computation, and what it is going to consider, how this reduction is possible, by considering the symmetry of circle. We are going to consider the symmetry of circle to plot it. Okay, so again I conclude for this particular slide is, okay, we are divided the circle into, we have divided the circle into 8 octants. Okay, 8 octants is divided, and you can find that if I get one point over here, okay, I will get minus x comma y. From this point reflection, I will get this point. Okay, this point is reflected here. You can find this point is minus y comma x. If it is reflected, I will get minus y comma minus x. Okay, because in this case y will be same. Okay, but x is positive here, but here it is negative. This particular point, if it is reflected at this side, okay, I will get minus. This is will be y will be minus. Okay, so y will be positive in this particular case. So y and minus x. Okay, so similarly, I will get all these points. Okay, so I will get all the points on my octant. Okay, so with this understanding, now we can move to the next point to understand. We continue our discussion of the midpoint circle generation algorithm. See, now as per the Breznam's line drawing algorithm, okay, we determine the closest pixel position to the specified circle path at each step. Okay, so I know what is my initial point of the circle. I know my first point of the circle. Okay, but after knowing the first point, I have to calculate the next point of the circle. Okay, for example, I want everyone to look at the diagram. Midpoint between candidate pixels at sampling position x of k plus 1 along the circle path. Okay, now I'm just going to explain this particular diagram. This is very important diagram to understand the circle generation algorithm. Okay, now assume that this is my current pixel. This is my current position of the path of the circle. Okay, once this is known to me. Okay, what is known to me? This is known to me. What is the value of this pixel? The value of pixel is y of k and x of k. This simply it is y x comma y. Okay, so this pixel is having the value x comma y. Okay, I'm having the value x comma y, but I'm just making x of k and y of k. So this pixel is x of k and y of k. Okay. Now after knowing this pixel, I have to calculate my next pixel. Okay. Now which is the possibility of my next pixel? My next pixel may be this, or it may be this pixel. Okay, because this is passing to the line. So my next pixel may be this, or it may be this particular pixel. So I have to select between whether this is the closest pixel or whether this is the closest pixel. Okay, which pixel is closest? Okay, now here you can find that I'm going to start from this pixel and I'm moving to the x direction. So the x value is always incremented. So my initial value of original pixel, current pixel is x of k, xk. So next value of x will be always xk plus 1. Okay, because this both the pixel, this and this, okay, both the pixels are having the value x of k plus 1. Okay, but now what about y? Okay, what about y? If I activate this pixel, what is the value of this? This will be y of k plus 1. Okay, and if this is the pixel activated, it is having the value y of k minus 1. Okay, so I have to decide whether I have to increment the y by 1 or I have to decrement the y value. Okay, so that is what I have explained here. Okay, I want everyone to look at the description. For a given radius r and screen center position xt comma yc, first we calculate the pixel position around a circle path centered at origin 0, 0. Okay, so we are going to calculate the first pixel, okay, through 0, 0. Then what we are going to do is then calculated position x comma y. Here we are considering xk comma yk. Okay, xk. So this is my xk and this is my yk. So position, each calculated position x comma y is moved to its proper screen by adding xc to x and adding yc to y. So if I add the center into the x and y, I will get this value. Okay. Now I want everyone to look at this. This is what we have learned through this diagram. In first quadrant, along a circle section x is equal to 0 and x is equal to y. Okay. So how I am moving in the first quadrant? I am moving in the first quadrant where the value of x is 0. Okay, x value is 0 and y value x means the x will move from 0 to y. Okay, so x will move from 0 to y. The slope of the curve varies from 0 to minus 1. Okay, now here if I am moving from x is equal to 0 to x is equal to y or x is equal to radius up to radius, then x is always incremented. You can find it here in this diagram. My first point is x of k. Next point is always x of k plus 1. X is always incremented. Okay, x is always incremented and use decision parameter. We are using decision parameter to determine which of the two possible y position which is closer to the circle path. Okay, you can find that x is incremented, but which are the two possible points where suppose this is y of k, then this value will be y of k plus 1, this value will be y of k minus 1. Okay, I will get this as y of k plus 1 and y of k minus 1. So I am getting this value. Okay, so I have to decide whether to activate this pixel. I make it as a question mark, or whether to activate this pixel. Out of these two pixels, which pixel is activated, which will be my next pixel. Suppose I get this is my next pixel. Again, I will check whether to activate this pixel or whether to activate this pixel. Okay, I assume that suppose this is correct. Okay, so now this will become my current pixel. If this is current pixel, again I have to decide what is my next pixel, whether this is my next pixel or whether the next pixel is this one. Okay, getting me? So this process will continue. Okay, suppose I get this is my correct pixel. My correct pixel is this. Okay, then I activated this. So again, next choice is whether to activate this pixel or whether to activate this pixel. So this process is continued. Okay, till I reaches my value of x is equal to, means I reaches to the one end of one quadrant. Okay, so this is the way we are going to continue. Okay, so we move to the next slide. Now we go into the more detail of the algorithm. Yes, what we are going to do here is Okay, now to apply the midpoint method, we define a circle function here. Okay, so to apply this particular method, we define the circle function where f of circle is considering the f function f of x comma y. So obviously we are knowing what is the function of the circle is x square plus y square minus r square. So x square plus y square minus r square, what is the expected value? It should be 0. X square plus y square minus r square should be 0 because we are knowing that the circle function is this. Okay. Now again we are considering the same diagram. Okay, so we are considering this is my midpoint. Okay, so this is my midpoint value, which is my current pixel. Current pixel is xk and yk, and I have to decide. Okay, so this is my, I think this is coming from the center of the circle. Okay, so this is my radius. I can consider this is my r value, and this is coming from the center. Somewhere center is here. Okay, so I'm getting from center this particular value. Okay, now if I consider any point x comma y on the boundary of the circle, so this is the boundary of my circle. Okay, remember this is the boundary of my circle. So any point x comma y on the boundary of the circle with radius r must satisfy the equation f of circle x comma y should be equal to 0. That is what I have written here. Okay, the value of x square plus y square minus r square should be 0. So f of circle x comma y should be 0. Okay, so if this is the correct point, okay, I assume that suppose this one should be the correct point, its value should be equal to 0. Okay, if this is the correct, that value will be should be 0. Okay, now if the point is in the interior of the circle, okay, this point is inside the correct path of the circle, it is interior, it is inside. Okay, then what is going to happen? The circle function is negative. Okay, so if this function value, what is the expected function value? 0. Okay, expected function value is 0. But if it is negative, means if it is less than 0, okay, if it is less than 0, what it indicates? Indicate that the point is interior, means inside the circle. Getting me? The point is inside the circle. And if the point is outside the circle, okay, if the point is outside the circle, the function is positive. Means if the value f of circle x comma y, if it is greater than 0, means it is positive. Getting me? If this particular value is positive, what it indicates? The point is outside my circle, because what is the correct value is 0. Correct value is 0. If it is less than 0, the point is inside the circle, interior of the circle, and if it is greater than 0, the point is outside the circle. Okay, so based on this value, I can find out which one is my correct pixel. Okay, so again I repeat, what is our current pixel? I just changing the color of my ink or the color. My current pixel, which one is my current pixel? This is my current pixel, having the value xk and yk. Okay, which are the possible next pixel on my circle? Maybe this one. Okay, I just underline this. This may be the next pixel, or next pixel may be this diagonal pixel. This is the diagonal, or this may be the next pixel. Okay, so I have to decide my question mark I'm making whether I activate this pixel or whether I have to activate this particular pixel. Okay, I have to calculate to understand this. What we have come to the conclusion is, again I'm using the f of circle function. I'm using f of circle x comma y function, which is nothing but x square plus y square minus r square. Okay, and what we are coming to the conclusion is, we are coming to conclusion, if this value is less than 0, indicate my next pixel is inside the circle, and if it is greater than 0, indicate that it is the outside the function or outside my circle. So my expected value is, it should be equal to 0. So x square plus y square minus r square value should be, expected value should be 0, and depending upon this I will find out which is my next. So the same thing is summarized here. Okay, so whatever I'm talking about, I have summarized this. F of x comma y, f of x comma y, or f of circle x comma y, what is our expectation? Equal to 0. If it is equal to 0, if x and y is in the circle boundary, if it is 0 means it is the correct pixel and it is on the circle boundary. If it is less than 0, okay, then x and y is inside my circle boundary, and if it is greater than 0, then x and y is outside my circle boundary. Okay, so this is what the summary, and based on this, okay, whichever is closest, that I'm going to select. Okay, and this is what the main basic thing behind the midpoint circle generation algorithm. Okay, so this is the main thing or the main point to understand for midpoint circle generation algorithm. Okay, so with this, let us move to the actual algorithm that we are having. Okay, so we are now discussing the actual algorithm. Okay, so now this is what the algorithm we are having. Okay, so as per our textbook, okay, as which is given in the textbook, we are just going through the same algorithm and which is having the name midpoint circle generation algorithm. Okay, I want everyone to just look at this. Input radius r, so which are the parameters we are consider radius r, and the circle center is xt comma yc. Xt comma yc is the center of the circle, r is my radius, and obtain the first point on the circumference of a circle centered on the origin as, what is my first point? My first point is x0 comma y0 or x comma y. What is the value of x0? X0 value is 0. Okay, value of x0 is 0. And what is the y value? Y value is considered as r. Okay, x0 and y0, r value is considered as, y value is considered as r. It is equal to r. Okay, this which is my first pixel on my circle. Okay, which is my first pixel, so I'm just drawing it here. Okay, suppose this is my, okay, y value and this is my x value. This is my x value. Okay, and this is my y value. Is it clear? Okay, now suppose this is my circle. Okay, this is the, I have having the circle in my one quadrant. Okay, so this is my circle. Okay, obviously we are considering what is this. This is the radius of the circle. Okay, what is this? This is the center of the circle. Okay, that is nothing but the, this point is xt comma yc. This is the center. Okay, now I have initialized my first point of the circle. Which is my first point? My first point is x value is equal to 0. So I can find this value, x is 0 and y value is equal to r. What is the value of y? It is r. So this is nothing but, in my algorithm, I consider this is my first pixel. Okay, I want everyone to remember this is my initial pixel having the value, x value is 0. So this is having the value. What is the value of x? X value is 0. And what is the y value? This y value is equal to r. Okay, this is my first pixel. Okay, now after that, calculate the initial value of the decision parameter as p0. P0 is my decision parameter and P0 is equal to 5 by 4 minus R. Okay, this is calculated, okay, based on the equation of the circle x square plus y square minus R square is equal to 0. Okay, so there is no need of to go into the more calculation or the detail. We consider the decision parameter is P0 having the value 5 by 4 minus R. Why this has to be 5 by 4? Because we are having 2x into 2y plus displacement as minus r equal to 0. So by calculating we get this. Okay. Now at each xk position, starting at k is equal to 0, perform the following test. We have to perform this following test because we have to calculate which is my next point. Okay. If pk is less than 0, if my decision parameter value pk is less than 0, just now we have learned, if it is less than 0 means it is inside. Okay, if it is less than 0 means it is inside. The next point along the circle centered on 0, 0 is x of k plus 1 and y. So here what is happened? X value is 0, so x is incremented. Okay, but y value is not incremented. Y value is y of k. Okay, y of k and x is incremented. So in that case, okay, I'm just changing the color. In that case, this will be my next pixel. Okay, my next pixel is this. What is the value of this? This is having the value. What is the value of x? Here you can find x is incremented. Okay, so x is having the value x. X is having the value x plus 1. Okay, and whether the y value has changed? No, y value will remain as it is. Okay, because here the y value is same, x is incremented. When it is the case, then the p of k is less than 0. Okay, now and the p of k plus 1 is equal to p of k plus, again I will recalculate the p value or the decision parameter. Okay, otherwise, if that is not the case, what it means? If the p of k is greater than 0, Okay, otherwise the next point along with the circle is x of k plus 1 and y of k minus 1. So if that is not the case, if this condition fails, okay, what is my next pixel? My next pixel will be this one. This is my next pixel. Okay, what is this value of this next pixel? Obviously x is incremented, so x is x plus 1, but y is decremented. So what is the value of y? Y is y minus 1 for this particular pixel. Okay, so that is what we have considered, because if the value of pk is greater than 0, my pixel will be outside. Okay, so that is what we are having, whether where 2x k plus 1 is equal to 2x. So these are the calculations that we are having. So we have done to recalculate it. Okay, so I can find out of these two which one is the correct pixel. Now determine the symmetry point in the other 7 octants. Okay, so if I got this is my correct point, so I will get its reflection over here. Okay, somewhere here I will get the reflection of this over here. I will get the reflection of this at this side, and so on. So all octants I will get the reflection. To determine the symmetry point in the other 7 octants, we will achieve the remaining 7 octants. Then move each calculated pixel position x comma y onto the circular path centered at x comma c and plot the coordinate values. So x is equal to x plus c, y is equal to y plus c, and again repeat steps. What we are going to do is repeat steps 3 through 5. Okay, so again we are going to repeat all this procedure. We are going to repeat this until the value of x is greater than or equal to y. Okay, what is my value of x? Value of x is 0. Okay, what is x point is 0. So I'm just moving till I reaches to this particular point. This point value of x is equal to y, or x is equal to r, rather we can say. Okay, so till then we are going to repeat. So I will find out which is my next point. Suppose this is, again I will continue. So in this way the process is continue, and I will get the one complete octant or the quadrant, and then I'm going to give for the reflection. Okay, so this is what our midpoint algorithm for circle drawing. Okay, how to draw the circle, that we are having the midpoint circle drawing algorithm. Okay, now we just see one of the example of this. Okay, we are going to see the example of this midpoint algorithm for circle generation. Okay, so that it will be more easy for us to understand. So we are having this slide. Next slide, we are having this example. Okay, now in the example, I suppose like I am calculating, given the circle radius r is equal to 10. I am considering the example as per our textbook. R is equal to 10. Radius of the circle is 10. Okay, then we demonstrate the midpoint circle algorithm by determining positions along the circle octant in the first quadrant. So obviously we are knowing this is the whatever I have drawn. This is my first quadrant. Okay, so this is my first quadrant. From x is equal to 0 to x is equal to y. So my x value will be 0. That is what I have shown. X is equal to 0 to x is equal to y. Okay, so I'm moving from this side to this side. So this is what the flow. Okay, I'm having. Now we are going to initialize these values. Initialize the decision parameter. Decision parameter p0 is equal to 1 minus r. Okay, so here r is 10. So 1 minus 10, I will get minus 9. Okay, so for the circle centered on the coordinate origin, the initial point is x0 comma y0 is equal to 0 comma 10. So I will get my first point. You can find what is my first point. 0 comma 10 means this particular pixel is activated. Okay, in the example I'm going to activate this pixel because this is 10 value and x value is 0. Okay, then I will get 2x comma is equal to 0 to y into y0 is 20 value. Now successive this parameter. Now I need to go through this loop. Okay, so we are moving to this particular loop. Okay, so k is equal to 0. So my first point is 1 comma 10. Again I will calculate. My second point will be 2 comma 10. Yes, you can find value of x is this. So this is my second point. Okay, 2 comma 10. My next point I will get 3 comma 10. I will get this is my next point. Again I will get this is my next point. Okay, 4 comma 9. Okay, now I will get this particular point as again 5 means these are the 3 pixels. So in this way I just goes on calculating my algorithm. Okay, so in this way I'm getting this algorithm, and somewhere you can find I will reach to the one octant. This is my one octant. Okay, so see that my quadrant is divided here into the two octants. Okay, this is my actually complete. This is my one quadrant. Okay, but now I have divided into this. I can say this is my, okay, I just change the color. See, this is my first or one octant, and this is my second octant. I will get this as a second octant. Okay, so I am reaching only to the one octant. So how many pixels are calculated? I calculated the pixel only up to this. Okay, and what is my last pixel which is activated? My last pixel is activated is having the value 7. You can find it here. X value is 7 and Y value is also 7. Okay, X is 7 and Y is 7. Okay, now if I reflect all these points, okay, if I get one octant, means my computation time is reduced. In midpoint algorithm, computation time is reduced. Okay, why it is reduced? Because I have to calculate only the circle pixels on one octant. Okay, and once I get this octant, I will reflect all these points and I will get this octant. Okay, by reflecting all these points, that's why it is shown in dotted line. This point is reflected here. Okay, I will get this point. This point is reflected here. I will get this. This point is reflected. I will get this. This point and the last. This point is reflected. I will get this particular point. Okay. So for this point, what is the value? The x value is equal to y, and what is the y value? Y is equal to 0. What was our initial value? Yes, everyone knows what is our initial value. X is equal to 0 or 1, but y is equal to r. Okay, that is what we have written. Okay, but here the case is completely reversed. Okay, for this point, what is going to happen? X is equal to, what is the value of x is equal to y or r, and y value is equal to 0. Okay, so this is what the simple way or the example which shows that how the circle midpoint circle generation algorithm works and how it is possible for us to plot the circle. Okay, so the main advantage of midpoint circle algorithm is the number of computation or the time required is very less. Why it is very less? Because there is no need to calculate all the points on the path of the circle. It is not needed. What is needed is we just have to calculate the points of the circle on only one octant. Okay, if this much is calculated, that is sufficient. I will get the reflection of this, I will get first quadrant. Reflection of first quadrant, I will get second quadrant. Reflection of semicircle, I will get the complete circle, and so on. Okay, so that's why this particular midpoint algorithm is always used in all the applications to draw the circle. Okay, because it is having the two important points. It is the number of calculation of the pixel required is very less. Okay, or it is one of we can say only for one octant we are calculating, and the computation time is also reduced. Okay, so that is the reason, okay, this particular midpoint algorithm or midpoint circle generation algorithm is more popular. Okay, I hope so all of you have learned the detail in detail how the circle is generated. Okay, or midpoint circle generation algorithm. Okay, so in the next lecture, before moving to the next point, we also see how it can be implemented using the C program. Okay, in C program, how I can write down the program, and after execution of the program, I will get the required circle with given radius by the user. Okay, so we stop here. Okay, and next lecture we continue. Thank you all.